All right, so this is the PreAP Unit 5 retest review, right? And this test was over systems of linear equations. So let's go ahead and get started. Don't forget that your retest is going to be very, very similar to these questions, and you want to make sure you can do them by yourself before taking your actual retest. All right, problem number 1, find the solution to the system below. Sorry, there we go. All right, so we've got y equals and y equals. The fact that they're both y equals should tell you that you want to solve by graphing. All right, because it should take just a couple of seconds here. Let's take a look at my calculator. We're going to go to y equals. We're going to type those in. So we've got x minus 3 for the first one. For the second one, we've got 7x plus 3. And I always like to look at the graph first. Hang on, my plot is on. All right, let's take a look. Okay, we can see the intersection looks like about right here, which to me looks like -1, -4. I always would check the table, so second graph, and just make sure. So -1, yeah, that's it, right? Because our y values are matching. Okay, so our solution for this one is simply found by graphing, and we got -1, -4. All right, the next one is a little bit confusing, because you definitely, if you want credit on this problem, have to solve the way they tell you, and that is by substitution. Okay? It is, however, set up for elimination. Like, in my opinion, if I were going to do this problem, I would use elimination. The reason this question is on your retest is just to make sure that if it tells you how to solve using substitution, that you are able to do that. All right? So if we're going to solve by substitution, we need either an x equals or a y equals. So as I look at these numbers, I think probably my best bet is to get this y by itself. We practice that a lot in class, and all I got to do is move one thing. That's going to be a pretty safe bet. So I'm going to add x to both sides here. So now I've got y equals -13 plus x, or x minus 13, right? Same thing. So now what I can do is I can actually substitute it into the other equation, right? So let me write this again. 4x plus 2y equals 10. And now I know that y is equal to -13 plus x, right? They're the same thing, they're equivalent. So I'm going to take this and I'm going to plug it in for y. So instead of writing y, I get to write -13 plus x. Everything else remains the same. So I still got this 2, right? 4x plus, I still have equal to 10. All that changed was that the y, we're writing -13 plus x because they're equivalent. And now this becomes a problem that I should be able to solve fairly quickly. Right, we've got 4x in the front, minus 26 plus 2x is equal to 10. My next step would be to combine my like terms. So I've got 6x minus 26 equals 10. And now I can start moving stuff around to both sides of my equation here. I'm going to add 26 to both sides, which means I've got 6x equals 36. Divide the 6, and we get x is equal to 6. There's a lot of 6's there. So for my solution, and the first one kind of reminded us how our solutions should look, hopefully. The first part of my solution is going to be 6. I still need to find the y coordinate. All right, so we're going to do some substitution here. Well, I did all this work to get y by itself. I'm going to use it. I got y equals -13 plus x, and I just figured out that x is actually 6. Right? So my solution here is -13 plus 6, which is -7. Let me just double check my math there to be safe. All right, we've got -13 plus 6. Yep, it's -7. So y is -7. So my solution for the y coordinate is -7. All right. The next one, however, is telling us to use elimination, which is great because that's how it's set up. All right, let's take a look. Elimination means that when we add our two equations, something should eliminate. Now, don't write this down, but watch. If I add it right now, I get -12x minus 4y. Okay, no, that's not what we wanted. Something is actually supposed to eliminate. So if this happens, you need to try and figure out what you want, because there are actually an infinite number of ways you could do this, all right? But we definitely want to look for the easiest way. Okay, So if I have a negative 16x on the bottom, I really would love to have what on the top? Hopefully you're thinking 16x, right? If I have negative 16x on the bottom, I would love 16x on the top. All right, well, why not just make that happen? You're allowed to do that as long as you're being equivalent and fair to your equation, keeping it balanced. So we're going to take the entire top equation and we're going to get what we want. Remember, we want 16x. Okay, well, how do I get a 4x to become a 16x? Multiply by 4. Right, 4 times 4 is 16. But you got to do it to everything because you got to be fair. So we got what we wanted, but now we have to finish doing it. So 4 times negative 3y is going to be a minus 12y. And 4 times negative 10 is going to be negative 40. The bottom equation did not change, so we just get to write negative 16x plus 7y is equal to 30. But now, when we add up our two equations, something's actually going to cancel, which is perfect. Right? Our x's cancel. So now we've got negative 5y is equal to negative 10. Divide out that negative 5 and we've got y is equal to positive 2. All right? So go ahead and put in your positive 2 for your y coordinate. And don't forget that you always have to find the other one. In this case, we got to find x. All right, so start with an equation, doesn't matter which one, and we're going to go ahead and plug it in. I'm going to just go ahead and use the top equation from the original, which was 4x minus 3y equals negative 10. Okay, but now we think that y is actually negative 2. All right, we want to use positive 2. We think that y is positive 2, so we have to use that. Everything else stays the same. We've got the 4x minus 3 times the 2, and it's going to be equal to negative 10. Now clean it up and solve it. That's your last job here. So we've got 4x minus 6 equals negative 10. I'm going to add 6 to both sides. So I get 4x is equal to negative 4. And then finally divide by 4. And we're left with x is equal to negative 1. So your solution for this problem would be negative 1, 2. All right, these are the three main ways that we learned how to solve. Be prepared to solve the way that you are asked on the retest. Okay, here we go. What is the solution to the system represented in the tables below? Okay, well keep in mind, a solution is where two lines are crossing, right? And if they cross, they only cross one time. They will only share one of the same points. So look at these tables here and try and find the same points. I've got 3, negative 8. Do I have 3, negative 8 in the right? Oh, actually I do. It's exactly the same point. Oh, that's your answer. 5, 0 doesn't show up again. 7, 8 doesn't show up. Yeah, that's the only one that works. So your solution is just 3, negative 8. Right? It showed up in the table, so you know that's where it crosses because it can only cross once anyway. All right, let's go ahead and look at the next page. Tammy bought 3 cheeseburgers and 2 hot dogs for $11.50, not including tax. Sam bought 1 cheeseburger and 3 hot dogs for $8.50, not including tax. What would be the cost of 4 cheeseburgers and 1 hot dog? All right, well, in my mind, the only way to do this is to figure out how much each cheeseburger costs and how much each hot dog costs, right? So I'm going to write 2 simple equations. 3 cheeseburgers plus 2 hot dogs is $11.50. So I'm going to say 3c plus 2h equals $11.50. Okay, the next one I read is that 1 cheeseburger and 3 hot dogs is $8.50. So 1 cheeseburger plus 3 hot dogs is going to be equal to $8.50. All right, so now we have to go ahead and solve this thing. And this is a lot like the elimination problem in number 3, where you kind of have to figure out what you need. Well, if I have a positive 3c up top, man, I would love a negative 3c on the bottom, so I'm going to multiply by negative 3, because that will give me what I want. Okay, so this equation becomes negative 3c minus 9h, and 3 times 850 is 25.5 negative 25.5. All right, and I'm adding that with my original red equation. I'm just going to rewrite it so I can see it easily. So plus 2h equals 1150. Okay, and now this is the equation that I have to solve. Well, the c's cancel, which is great. And now we're left with negative 7h is equal to negative 2550. Whoops. So negative 2550 plus 1150. And I get negative 14. We're dividing out the negative 7, and we get h equals 2. So it looks like hot dogs are $2. All right, so I'm going to just write down here, hot dogs are $2. All right, now I still got to figure out the price of a cheeseburger. Let's see here. Well, if I know that hot dogs are $2, I can just plug that in like I've been doing, right? Like I've been practicing. So I'm going to take the first equation, the red equation. I'm going to write 3c plus 2h is equal to 1150. And now I'm going to plug in the fact that I know one hot dog is $2, right? Hot dogs are $2. So 3c plus 2. And like I said, hot dogs are $2. So we're going to plug in a 2 right here. So I've got 3c plus 4 is equal to 1150. And this is perfect because this is very simple to solve, right? We should have lots of practice solving these. So I've got 3c is equal to 1150 minus 4, which is going to be, I believe, 750, but it's kind of late, so I'm going to double check. Okay, 1150 minus 4. All right, we got 7.5. Divide by 3. We've got cheeseburgers are $2 and 50 cents. Okay, now let's double check, right? Divide by 3. Yeah, $2.50. Okay, now be careful, be so careful because we have not answered the question yet. The question on this problem said, how much would 4 cheeseburgers and 1 hot dog be? Okay, the cost of 4 cheeseburgers, let's do a different color, how about green? All right, 4 cheeseburgers is going to be 4 times 250, plus 1 hot dog would be plus $2. All right, so 4 times 250 is $10 plus $2, y'all. That would cost us 12 bucks. Whew, that was a lot of work, but we got through it, right? Set up a system, solve it, plug them in to find that final answer. All right, problem number 6, we're actually not solving anything, we're just writing a system. And this looks like we're dealing with money. So before I do anything else, I'm going to write myself a little hint. And over on the side, I'm going to write myself 2 questions. I'm going to say how many, and I'm going to say how much. All right, I promise it's super helpful. All right, let's see here. 500 tickets were sold for a recent Justin Bieber concerts. Adult tickets sold for $7.50 and child tickets sold for $4. It's a very discounted sale, okay? Ticket sales for the concert totaled $3,312.50. Write a system of equations that can be used to find the number of adult tickets A and child tickets C. So they want us to use A and C for our variables. All right, here's my best hint. For the how much equation, you're looking for money. Anything with money should be in the same line, the same equation. So I see $7.50 for adults. Child tickets are $4. Total money is $3,312.50. Money, money, money. That all goes together. I think we can agree that everything's going to be totaling $3,012.50. Okay? All you got to do now is use the correct variables with the correct numbers. So we're going to say 7.5 for adult tickets, so A, plus child tickets for $4, so 4C. Okay, one more time, y'all. Money goes with money goes with money. Those should all be in the same line. The only other number we have left here is just 500 tickets total. Okay, well, we have to use the same variables. It's a system. So we just get to say the adult tickets plus the child tickets for 500 tickets total. All right, if you can get money, money, money all together, then the other one is just how many, right? The different variables totaled up give you 500. All right, problem number 7. The perimeter of a rectangle is 34 inches. Y'all need to know the perimeter formula is 2W plus 2L. If you know this, which you should, you can write your first equation really pretty easily. 2W plus 2L is, in this problem, 34 inches. All right, there's one equation. The second equation is going to come from our second sentence. Let's see here. The length is, okay, stop. If you actually read something that says the length is, then you stop writing it and you write L equals. This right here is your favorite thing, your best friend, the nicest thing we could have given you, because that tells you how to set up this equation. The length is, we're saying L equals. All right, keep reading. 2 inches more than. All right, well, this right here is a switch phrase. I hope you remember, which means that we're going to say, okay, something, 2 more than that. All right, so something plus 2. We're actually writing things in reverse from how we normally would. All right, so 2 inches more than what? More than twice the width. So 2W. All right, so we've got 2W plus 2. The length is 2 inches more than twice the width. Okay, last but not least, let's look at problem number 8. How many solutions, if any, does this system have? Well, remember, if the lines cross, there's one solution. If the lines are parallel, there's no solutions. There's also the possibility they could be overlapping and only showing up once. Okay, let's see here. Do these lines have the same slope? You know what? I don't feel comfortable saying yes or no until I get y by itself. So we're going to do that. We're going to get the x moved to the other side. So now I've got 2y equals positive 3x. Right when we move it, we change the sign. I don't need to write that. Okay, we change the sign, which means that now it's a positive 3x with that 6 that was already there. Divide by 2. We've got y equals 3 over 2x plus 3. Do the same thing with this other equation. Move the 3 to the other side. We've got a minus 3x, so we've got y equals negative 3x with that negative 2y equals negative 3x plus 8. Divide out that negative 2, and we've got y equals positive 3 over 2x minus 4. So these are our two equations. Which of these things is happening here? Well, hopefully you realize that they're not exactly the same line, but they do have the same slope. Y'all, they are parallel. They have the same slope, so we say no solutions. All right, no solutions. All right, problem number 9. We're looking at this teeny tiny little graph, and we're finding the solution. You definitely should know the solution is this point where they cross. So we say 10, 20. Okay, in problem 9, which company from the graph would you use if you wanted to talk for 20 minutes? All right, well, 20 minutes hits this line first, right? So that means, let's erase some of this. So that means that the cheapest line, right, is actually this one right here. This is the one it hits first. 20 minutes hits this line. So we want to use company Z. So company Z, because it is cheaper at 20 minutes. All right, and we are assuming that, yes, everyone wants to save money and everyone will always choose what is cheaper, okay? All right, y'all, keep in mind, you have to be able to solve these problems on your own for the retest. If you have any more questions, make sure you ask your teacher before retesting after you have obviously completed this video. All right, good luck.